Okay, so now that you guys know what is potential difference or voltage and how you calculate it, let us look at more details about potential difference. Now, the way that we measure potential difference or voltage is by using a voltmeter. Now, this is how a voltmeter actually looks on real life. It's this picture on page 110 of your textbook. It just looks like some kind of equipment with some numbers, and you can see there's a V for voltage, and then you have some of this dials here. And a voltmeter is always connected in parallel across a cell, battery, bulb, or resistor. So you'll never see a voltmeter in series. There will always be a branch with the voltmeter, and it will always be across the cell or battery or the bulb or resistor. So you'll see the cell, battery, bulb or resistor, and then there will be a branch across it, and on that branch you will have the voltmeter. So the voltmeter will always be connected in parallel. Just remember that. Now, last year we did a whole lot of work on electricity and series and parallel circuits and how voltage and current is measured in those circuits, and we're going to do the same thing this year. So I want you to look at your grade 9 notes and go back to it and revise what we have done last year, because it's the same thing that we're going to do now. Now, voltage in a series circuit and in a parallel circuit is completely different, and they work differently, and you calculate it differently, and all of those things. Now, the first thing we need to know is, for a series circuit or a parallel circuit, the total voltage of the entire circuit is equal to the voltage across the cell or battery. Now, normally you will see, if you go, for example, on page 110, you'll see you have this circuit here. Now, here is the battery. It's made up of 3 cells. And can you see you have a parallel branch across the cell or battery, and you have the voltmeter V1 attached to it. This just shows that the V1 voltmeter is in parallel across the battery. So the voltmeter is always connected in parallel. Now, whatever voltage the voltmeter reads that is across the cell or battery, so here's the battery and here's the voltmeter, whatever reading this voltmeter gives you, that will be the total voltage for the entire circuit. So because this V1 is across the battery, it's 4.5 volts is the entire voltage of the circuit. Right, so anytime you see a cell or battery, the voltmeter across it like this will give you the total voltage. The same when you're looking at this circuit here. Here's the battery, here's the voltmeter attached in a branch parallel to it, and the voltage is 4.5 volts, and that 4.5 volts shows the total voltage of the circuit. So whether you have a series circuit or a parallel circuit, the voltage you have across the cell or battery is the total voltage of the entire cell. Now let's move on to specifically a series circuit. Now in a series circuit, you don't have any branches. There is only one pathway for current to flow. And in a series circuit, the voltage is divided, which means you're going to take the total voltage that you have across the cell or battery, and you're going to divide it across everything in the circuit. So if you have 2 light bulbs in the circuit, you're going to take the voltage and divide it amongst those 2 bulbs. So each bulb will have some of that voltage, but it's going to be divided. Now, it may not be divided equally, we will get to that later on, but it will not be the same as the total voltage. And when you add all of those voltages of the cells or the bulbs or the resistors, that will give you the total voltage. So basically, total voltage is the voltage across the cell or battery. If you have a series circuit, the voltage is divided across each bulb or resistor, and when you add all of those voltages of each bulb and resistor, you will get the total voltage. Right, let's go to page 110 of your textbook, and we can see how it actually is in real life. So here you have a circuit. Now, you need to be able to tell the difference between a series circuit and a parallel circuit. When you want to see whether a cell is series or parallel, you need to look at the light bulbs or the resistors. If the light bulbs or the resistors are all in one flowing circuit, it's a series circuit. If they are branched, then it will be a parallel circuit. Now, if you're looking at this circuit here, you see branches. Here's a branch, here's a branch, here's a branch, and here's a branch. But just because there are branches, it does not mean it is a parallel circuit. This circuit here is actually a series circuit. This branches that you have of V1, V2, V3 and V4 is just the voltmeter. And remember, we said voltmeters are always connected in parallel. So even if it's a series circuit, the voltmeter will still have branches. So this here is a series circuit, but the voltmeters are in parallel. And you can see that these two bulbs here are next to each other. So because they're next to each other, this makes it a series circuit. So ignore all of the voltmeters in a circuit if you want to see whether a circuit is series or parallel. And if you take out all of the voltmeters and you don't have branches, so for example, if you take out this here, can you see there is no branches? So this tells you it's a series circuit. Right. Now here is the total voltage, which is 4.5 volts because it is across the battery. Now in this particular circuit we have two light bulbs. Here's one and here's another one. Now because it's a series circuit, voltage is divided, which means all of this 4.5 volts is not going to go to this bulb and it's not going to go to this bulb. It's going to be divided amongst these two bulbs. So can you see we have 4.5 volts and you divided half of it here, so 2.25 volts is going to be here, and then the next 2.25 is going to go to the second bulb. So each of this here is divided, and if you add this 2.25 to this 2.25, you will get the total, which is 4.5 volts. So it's a series circuit, voltage is divided. If you add them, you will get the total voltage. Right, now in this particular case, you have the two light bulbs, and this total voltage is divided equally amongst them. But sometimes this is not the case. You may not have an equal division between voltages. Sometimes the one light bulb can get more and the one can get less. In this case, they just happen to be equal. Right, now if you look at V4, can you see V4 is also in parallel because it's a voltmeter, and V4 is showing you the voltage across this light bulb and this light bulb together, which basically means they are showing you the voltage of the entire circuit. So the reason why V4's reading is 4.5 volts, which is also the total voltage, is because it's reading the voltage of both light bulbs together, which is the total voltage if you add it together. Right, so to conclude, for series circuit, voltage is divided, so that's why this two bulbs is divided, and if you add them, you will get the total voltage. This one gives you the total voltage because it's showing you the voltage of both light bulbs together. Right, let's move on to a parallel circuit. Now for a parallel circuit, the same thing applies with total voltage. It's still the voltage across the cell or battery, but the opposite to a series circuit, in a parallel circuit, voltage is actually the same or equal in all of the parallel branches if there is nothing else in series. So in a series circuit, voltage is divided, but in a parallel circuit, voltage is actually the same or equal everywhere where it's a parallel branch. Right, let's look at this in an actual picture. Now we're going to this circuit here, the one next to it on page 110. And can you see here, V1 is across the battery. That's why it's giving us 4.5 volts, which is the total volts. Now, this circuit here is a parallel circuit. And again, the way you see if something is parallel, you ignore all of these voltmeters because voltmeters will always be in parallel. So if you ignore that, you'll see that this is gone and this is gone. And that still leaves you with two light bulbs, and those light bulbs are still both in parallel because there's a branch here and here's another branch. So this circuit is a parallel circuit. Now, since it's a parallel circuit, we know that the voltage must be the same everywhere. It's not going to be divided like in series. It's going to be equal everywhere. So if the total voltage is 4.5 volts, it means the voltage across this light bulb is also 4.5 volts. The voltage across this light bulb is also 4.5, and the one which is V4, which is showing the total voltage also, is also 4.5 volts. So basically the voltage will be the same everywhere in a parallel circuit. Can you see? It's always 4.5. So that is the difference between series and parallel. Series circuit, voltage is divided. If you add it, you will get the total voltage. In a parallel circuit, voltage is the same everywhere. Right, so I want you to go and read this and see that it makes sense, and go over your last year's notes because it is exactly the same like what we did last year. Right, let's move on to some more theory. Now, so far we have been looking at batteries and cells, and you know cells and batteries, the function of them in a circuit is to provide energy for the circuit. So in real life you know about cells and batteries. So here is how batteries look, and batteries actually contain chemical energy in them. So in the battery you have chemical energy, and the chemical energy is then converted to electrical energy inside the cell, and inside the circuit, and if you have a light bulb in the circuit, then you will get light energy. If you have a heater, then you'll get heat energy. If you have a buzzer, you'll get sound energy. Now, another new thing we are going to learn about is what we call EMF. Right, EMF, here is a definition here. There's actually two definitions. The one definition is EMF is the amount of energy that enables the cell or battery to allow 1 coulomb of charge to pass through the cell or battery. Or another more practical definition of EMF is it is the potential difference across the cell or battery when no current is flowing. Now EMF, you will hear it sometimes, it is almost the same as potential difference or voltage. So we have done potential difference and voltage already, you know what it is. EMF is the same as potential difference, but it is the potential difference or the voltage when no current is flowing in the circuit. So basically, the only time no current flows in the circuit is if the circuit is not working or something is broken, or if all the switches are open so no current can flow through. So if no current is flowing, then we call that potential difference EMF. And if there is a current flowing, it is no more EMF, it is potential difference. So as soon as there's no current, it's EMF. As soon as there is a current, we call it the normal potential difference. And since EMF is actually potential difference, it's also measured in volts, just like voltage. And EMF will always be larger than the potential difference. So they are both voltages, EMF and potential difference, but EMF is the larger one. Okay. Right, now we know in real life if we have a battery, sometimes they go flat or sometimes they stop working anymore, and when they stop working, they cannot supply energy to the cell or to the circuit, and the circuit or the appliance or whatever you're using won't work anymore. Now when a cell or a battery is flat, it actually means that all of that chemical reactions happening in the battery stops. So there's no chemical reactions happening, there's no chemical energy being supplied, and since there's no chemical energy, you cannot convert it into electrical energy, and therefore the cell does not work. So when a cell is flat or a battery is flat, that's what it actually means. There's no chemical reactions, there's no chemical potential energy being converted into electrical energy, so there is no charges that can be used to make the circuit work. Right, one last more thing is how to calculate the voltage or the potential difference of cells in series. Now we're doing cells in series, and when you put many cells together in series, it's actually what we call a battery, and this is how it looks. So you have one cell. Remember, a cell is a big line and a small line, and here in this particular picture we have 3 of them next to each other. So because they're all next to each other, they are in series, and cells in series is actually what we call a battery. Okay, right, now in this particular case we have 3 cells in series. Now if they ever ask you to calculate the voltage of this entire 3 cells, all you have to do is add each individual cell's voltage to each other. So for example, in this picture we have 3 cells, and if they told us that each cell is 1.5 volts and we need to get the total voltage of this entire battery, which is made up of 3 cells, all you do is you say 3 times 1.5, and that will give you a total of 4.5 volts. So one more time. If you have cells in series and you want to get their total voltage, you just have to multiply how many cells there are by the voltage of each one. So if each one of them is 1.5 volts and there's 3 cells, you're going to say 1.5 times 3, which will give you a total of 4.5 volts for this battery here.